collaboration, as I mentioned, focuses on technologies for freshwater production, for clean energy. And so some of these technologies, for example, in the energy, looking at new methods for, let's say, enhancing the electrical properties of silicon, so that you can have more efficient production of electricity. And this is for, let's say, photovoltaic solar applications. Another project is in the CO2 capture. Other projects involve, I'm trying to remember, the conversion, thermal electric conversion. So these are a few of the energy-related projects. One that I've been also participating in is in developing textured surfaces and coatings, so that the dust and water does not stick to the PV solar panels. In the Gulf region and some other regions, as you know, there are sandstorms and dust particles in the air, and they combine with the humidity in the air, and then they stick on these panels. Sometimes their efficiency goes down very quickly, maybe from 1 to 10% degradation, in a very short time, and then it increases, over time. And so in this particular project, as I mentioned, we're developing methods of texturing the surfaces and also different types of coatings, so that you can have, let's say, like non-stick surfaces, and at the same time maintaining the optical properties so that it can absorb the light in a proper way. So these are some of the projects in the energy area. For the water, also a whole series of projects in the membrane technologies, different types of coatings, because in the desalination of water you have fouling of these membranes. Let's see, using also nano structures for these specific devices. Another project that I'm involved in is in the leak detection. So these are inspections and contaminations when you have pipes, in this case, let's say for water, and they leak, so you lose energy, you lose the water, you also have contaminants, in fact, that go back in the water systems and can be very harmful. So these are all varied types of technologies, as I said, that are part of this collaboration. I'm also directing the Mechatronics Research Lab here at MIT. And so in this lab we focus on design, modeling, simulation, and this is all of engineering systems. We do instrumentation, control theory, and also the implementation of control algorithms. The applications up to now have focused on two main areas. One is in the robotics and automation, and then the second one is in the energy or energy systems. So a lot of the funding comes from companies, and so we work with them on developing future technologies that they need, whether they are using them in their factories or perhaps as part of the new products that they do. And so a lot of the work that we do has, of course, an analytical component and theoretical aspect to it, and of course an applied side. We design, we make prototypes, we test them, we make lab scale versions of these designs, and they involve many different things. They involve, as I mentioned, the electromechanical designs, optics. They involve the interfacing between the machines and the computer systems, the data processing, the control systems. Yeah, so we do all of that, because in a lot of these special applications, it doesn't make sense to have the design made by, let's say, different people. So what we found out in these specialized areas, that you have like the same people that have the knowledge of all these disciplines, and they understand it, and then we design them all together so that these machines, or instruments, have the performance that is needed. Yeah. So this is basically what we do in the lab, and we have worked and we continue to work with major companies here in the U.S., in Europe, in Southeast Asia.